The importance of the surface area to volume ratio. The what? I can explain. I've got my giant hamster ball back, as a representation of biological cell. Remember from the other video, we talked about how one of the main functions of the cell is to keep the outside out and the inside in. And that is done actually by the cell in a very regulated fashion, because you need nutrients to get in so you can build things, but waste products are produced, and those waste products need to get out. So, and all of that has to cross this plasma membrane. So it turns out that the actual surface area of the plasma membrane is important. That is the part of the cell membrane that is exposed to the outside. But there's another really important factor, is that the surface area to volume ratio is really important. Okay, so this is the giant hamster ball that's about the size of a eukaryotic cell, and this is a ping pong ball, which is approximately the size of a bacteria. You can see they're quite different in size and volume, but I want to show you how that surface area changes relationship to that volume. Now, there are a number of ways to calculate surface area and volume, but to me the easiest thing to do is to simply wrap the ping pong ball in a piece of paper, and then we can measure the paper. We can do the same thing for the hamster ball. Okay? So here's my piece of paper. I wrapped it in my ping pong ball. You see it's approximate. It's not exact, but it's approximate. So when we do that, it turns out that this piece of paper, like that, okay, is 19 square inches or 126 square centimeters. Okay? Now let's do the same thing for the hamster ball. Here's my piece of paper. And you see it's approximately wrapping the hamster ball. When we do that, this sheet of paper ends up being 478 square inches or approximately 3,000 square centimeters. Quite a large difference. To compare them specifically, visually, you can see this is the surface area of the ping pong ball, approximately, and this is the surface area of the hamster ball, approximately. There's quite a large difference. And actually, it takes 23 of these ping pong balls to equal the surface area of the hamster ball. So now we've determined the surface area of the hamster ball and the ping pong ball, and we've shown that it takes 23 surface areas of ping pong balls to cover the surface area of the hamster ball. But what about the volume? Remember we were talking about surface area to volume ratios? Well, the easiest way to do that was just to fill the hamster ball with ping pong balls. Remember I said there was 23 ping pong balls to cover the hamster ball? Well, there's 120 ping pong balls inside the hamster ball, so the volume difference is substantial. The surface area of those 120 ping pong balls actually makes approximately 2,300 square inches or 15,000 square centimeters. That's approximately 5 times the surface area of the hamster ball. So you see, by being small and occupying the same volume, you end up with a lot more surface area. So it depends on what you want to do, whether you want to be a big cell or a little cell, okay, as to what you want to transport back and forth. So it depends on what's going on. But in that hamster ball, there are a lot of ping pong balls. You want to see how many? That's a lot of balls.